The problem we, Professor Gautham and myself, Sam Paul, have given for the drug discovery hackathon is to improve the efficiency of the MLS algorithm in terms of sampling, scoring, and the computational time. The two challenges to be addressed here, the first one is to identify promising drug repurposing candidates using the IMOLS-DOC docking algorithm. And the second challenge is to reduce the computation time in IMOLS-DOC. IMOLS-DOC is an induced fit protein ligand docking tool that uses the MOLS technique to sample the ligand pose as well as the protein conformation. The inputs required for docking, protein ligand docking in IMOLS-DOC are the ligand structure, protein structure, binding site information, and also the number of runs, which is the number of structures to be generated. IMOLS-DOC, which is packaged inside MOLS 2.01 software package, could be downloaded from the web address given here. And here we have also shown the opening screen of the MOLS 2.0.1 software package. The first challenge is to identify promising drug repurposing candidates using IMOLS-DOC. Input for IMOLS-DOC are first ligand, which is a FDA approved drug, second receptor protein structure, third binding site information, fourth the number of structures to be generated, and the output from IMOLS-DOC are the minimized protein ligand complex structures. The scoring function in IMOLS-DOC is the sum of intra-ligand, intra-protein, and protein ligand interaction energy. The protein ligand complex with the lowest score is considered as the best solution. And we can also analyze the binding of ligand to the receptor protein by checking the hydrogen bond interactions between the protein and the ligand. The second challenge here is to reduce the computation time in IMOLS-DOC. In IMOLS-DOC, both the protein and the ligand undergo MOLS sampling and then conjugate gradient minimization. If we reduce the computation time by parallelizing both the MOLS sampling and the conjugate gradient minimization part, we can easily reduce the computation time in IMOLS-DOC. To parallelize the MOLS sampling and the minimization part in IMOLS-DOC, first of all, we have to download the source code from the website given here, and the subroutines that are responsible for MOLS sampling and minimization in IMOLS-DOC are given here, which is the subroutine MOLS and the subroutine S minimis. The first expected outcome is promising anti-COVID-19 drugs will be identified using IMOLS-DOC docking algorithm, and the second outcome will be by parallelization of IMOLS-DOC to run efficiently on CUDA enabled GPUs, we can easily speed up the overall calculations by at least 35 to 40%.